Okay, this is a regression with the time series data. So we will keep going on to the regression, but this time the data itself is the time series. So the data we use so far is what we call this cross-sectional data. So each observation is an individual. So usually it's like a customer, different customer, how much the customer purchased, what is the age, house, car, something like that. So actually, we don't have an order of the data. But today, we're going to do the regression on the time series data. Here, the data is the time. So we are measuring same thing over the time. So there is clearly the order. So the information is not the individual information. That's the ordered by the time. So nature of time series data is that actually there's a clear ordering. So 1900, so it's 1900 and 1901, 1902. So we collected exactly the same data but different timeline. So there is clearly the order, which one happens first and then what is the next one and what is the next one and so on. So we cannot mix up the data. This case, we will talk about can we use the past data to predict the future, and also we will talk about the correlation, not by feature, independent variable by independent variable. It's the same value, but the last year's or last year, and 3 years ago, and so on. So that's why we talk about the serial correlation. And also a lot of the economic value is like a GNP. So every year the country calculated what is the GNP, right? It's Dow Jones. So it's stock price also, right? So you can have every minute stock price data, every hour stock price data, every day stock price data. So we are measuring same thing, but over the time, so it keep changing. We collect that data. That's what we call the time series data. Time series are sequence of the random variable. That's what we call this stochastic process. But you are having a random variable again and again. Randomness does not come from the sampling from the population because we observe the same thing again and again. This is not random sampling. That's why the randomness is not coming from the sampling. This is so actually there's some other factor we don't know that is coming the source of the randomness. So example of time series data is, as you can see, this is a year and inflation data over the year. And also you can get the unemployment rate. That's a typical the economics data, but usually we are measuring the same thing. We are measuring inflation every year. So 8.1 minus 1.2, 1.3, that's the inflation. All of this data is the same measure, but different time point. Right? So we can have a way more than just two, but this example has two variables. So our time series analysis focusing on the dependency of the past or present. So this is more like a time, not the variable by variable. Can we make a regression with as a the past data as a independent variable? This is an example. The static model is what we call the static model is can we use just like what we did in the cross-sectional data, can we use the one time and one timeline and one timeline? So can I calculate the inflation using the unemployment? So we treated a one timeline data as a individual observation. So we will use, can we predict something? This is a model rate at time t. So we are using the same time information. This is what we call the static model. So we are not looking at the past. We are not predicting the future. So we are just using our current information to get our independent variable is also the current information. So this is a model data. Current model rate determined the current conviction rate and current unemployment rate and so on. This is what we call the static model. This is nothing different from the cross-sectional data analysis. But can we make it dynamic? Here the dynamic means can we look over the time? So this is what we call the lag model. Lag is like a kind of the delay. So usually something, so this is like a child born 1000 women. So this is like a fertility rate. But the child born actually takes time. So when they decide to have a baby, baby is not just coming out like one day later, right? So it takes like 9 months to have the child born. So if we trying to boost up the child fertility rate, we're trying to do a lot of different things, but that the effort will result in about 1 year later the baby come out, right? So whenever we do something, actually that will affect the 1 year later the baby born. So similarly, can then take a same, actually this is the same information, PE, it's a tax, the tax exemption. So current same year or 1 year before or 2 year before. So can you use the same, actually this is all same variable, but different time period. So can we use a last year's information and then last year's information? Because obviously the tax exemption, if the tax exemption boosts up to the child born rate, that effect comes realize. I mean, that will realize it's 1 year later, obviously. So can we not only when we do the regression, I want to know what is the effect, how much is the effect. Actually, this is helpful to boost up to the children born rate or not. So that's what we are trying to do, what we are trying to find out. That's why we do the regression. So obviously we are interested in what if the 1 year before something happened that affected the right now. We don't know yet. So that's why we trying to run the regression here. So this kind of the model, same thing, but previous year and last year's information, that what we assume is the 2 year before the tax exempt will affect the current children born fertility rate. So that's why we call this is a lag model, and this is really the point of the time series regression model. Interpretation of the effect in the finite distributed lag model. We have clearly there's a cut. Current information 1 year before or 1 period before, 2 period before, up to the Q period before. So when we have only one things, you take a look at the only one things. Actually, that what doesn't matter what is the lag, that will affect the current independent variable right away, and then that's it. This is the what we call the transitory shock, because that will affect it. It takes time actually the effect realize. That's why there's a difference t minus s versus t. However, that effect doesn't last. It takes time, but it appears and then gone. However, something has a keep affecting the other things. So if this is the case, you have to, I mean, the like 3 years before still affect the current situation. Last year's things also affect the current years. So which means if we have this kind of the equation, because the last years affect this year's, but next year, so last year will becomes like 2 years before, right? So that will affect the same thing. So if there's something happen like last year, something happened that will affect this much to the today. But when we do the y t plus 1, this one will becomes t plus 1 minus 2, right? So if this will becomes like 2 years ago in next year. So you will have another one. So effect can be stronger or weaker, but still this will affect the next year and then next year and next year. So the magnitude of effect will can change or decrease or increase. However, whatever it happen will keep affecting our future independent variable. That's why it's like a permanent shock. So this is a graphical illustration of the lag defect. Coefficient, as you can see, the 0 has a certain impact, and then 1 has a lot of impact, and 2 years before small impact, 3 years before and 4 years before doesn't have actually this is a 0, so it doesn't affect at all. So right now 1 year before, so 1 year before has the highest impact, and then 2 year before is a small but still has some impact, but third year, fourth year doesn't have any impact. This is of course this is just one example, but you can see how it affected my current YT. This is the zero lag, means the about the variable t, because the lag is 0, and then this is about the x x t minus 1, and this is about the x t minus 2, and this is 0, so we don't have. So this is just a simple example. Maybe you can have the positive effect here, or sometimes the current is the biggest and then it's going down, or sometimes it's like a second is the biggest. So a lot of different things can happen here. We don't know. That's why we have to learn the regression.